Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Today, I will give you material about the second order ODE. So, after we finish the discussion about the first order ODE, today we will start to second order ODE. Okay. So the difference between the first order and second order, I have explained in the beginning of this is ODE. That is, this is the general form of the second order. A d quadrat y per dx quadrat plus b dy per dx plus cy is equal to 0. So this is the order. So the order is 2. The highest derivative, we can see that the highest derivative is here, is 2. So we have the second order because the highest derivative is second order. Okay, and then this is a linear because of y and r, its derivative are 2 degree 1. Yeah, okay, the degree is 1. So the linear, because the variable of y and its derivative is degree to 1, and it has a constant coefficient, as we know that the coefficient is a, b, and c. So this is the constant coefficient. So if the right side is 0, I mean that here is 0. So it means that this is the homogeneous. So if it's non-zero, so it is non-homogeneous. So because this is the second order ODE, so we expect that the general solution is they have two arbitrary constant. So the general solution is two arbitrary constant. So we have the two arbitrary constant. Yeah, so maybe I put A and B. So because this is the second order. Okay, so how to get the 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 general solution of second order ODE to find arbitrary constant of A and B. So the first one, we have to try trial solutions. So we have to try a trial solution of the form of y is equal to a e power of mx. This one, so we call it auxiliary equation. And then we got that from the general form. We can we find that we can write like this one, a, because this is the second order, am quadrat plus bm plus c is equal to 0. So the solution of this equation is um, the solution, they have two routes, so they have a two routes. There is M1 and M2, so this is the route. So M1 and M2, and then how to find the routes? We have a three characteristic of the route. The first one is if they have a real different routes. So if we have for the equation, we have the real different routes. So we have the M1 and M2. So the solution is y is equal to y1 plus y2 is equal to a sorry, a e power of m1x plus b e power of m2x. So this is the general solution if we have real difference rows of our m1 and m2. And then the second, if we have real equal rows. So like m1 is equal to m2, so the y is equal to y1 plus x y2. So we get that a plus bx e power of m1x, like this one. So this is the solution if we have a real equal roots. And then the third one is we have the complex roots. If we have complex roots at p plus minus I key, so the general solution of y is equal to y1 plus y2 is equal to e power of px a cosinus kx plus b sin kx, like this one. So this, if we have the complex root, so we have the solution of e power of px, a cos kx plus b sin kx. So this is a three possible solution in a second order differential. Okay. So the first one we have to, I give you an example. This is the example how to find it. And for number one, if we have like 2y double accent plus 2y accent plus minus 2y is equal to 0. And note that y double accent is mean that this one, and then y accent is mean that dy per dx, like this one. Okay, so this is the example number one. So how to solve this one? Okay, so the first one we have to assume we set that y is equal to like this one, a e power of mx. So dy per dx is equal to m a e power of mx. So because of a m mx here is y is equal to y, so we can write that dy per dx is like my. And then the second is d quadrat y dx quadrat is equal to m quadrat a e power of mx. So it's similar. A e mx, this one is equal to y. Yeah, here this is y. So it means that the d quadrat y per dx quadrat is equal to m quadrat y. Okay, so we can write this equation by 2m quadrat y, because of here 2y double accent. This is the y double accent. See, this is m quadrat y. So the coefficient is 2, so 2m quadrat y plus this one. This one is y accent, right? So this is the coefficient is 3, so 3m y minus 2y is equal to 0. Okay, so this is we can divide by y, so we can get like this one, 2m quadrat plus 3m minus 2 is equal to 0. So we can divide it like this one, 2m minus 1 and m plus 2 is equal to 0. So m1 is equal to a half and m2 is equal to minus 2. So this is the m1 is a half and m2 is minus 2. So we have the different roads here. So this is the different road. So we have two independent solution. That is y1 is a e. Okay, look at this one. So aem1x. So aem1x. So m1 is a half. So we get that a e like this one, power of half x, and y2 is b e m power of m2x. So we have that b e minus 2x power of minus 2x. So we get this equation. So the general solution is y is equal to y1 plus y2 to get a e half x plus b e minus 2x. Okay, so this is the general solution of these equations. Okay, so this is the first example, and this is the second example. We try to find if they have the second real equal roots. So this is number 2 here. So if we have y double accent minus 2y accent plus y is equal to 0. So we can write by using similar solution with this one. So we set like this one, so we can get that this equation become m quadrat minus 2m plus 1 is equal to 0. So the roots is m minus 1 quadrat is equal to 0. So the root is m equal to 1. Okay, 1 and m is equal to 1, like twice. Okay, so we have equal real roots. Okay, so how to find this equation? So we have that for the equal real roots, the solution is y1 plus x, y2. So we can get y1 is e power of x plus x, y, because the m is equal to 1. So ie power of mx, we can write like this one, ae power of x plus x b e power of x, or a plus bx e power of. So this is the general solution of the example number 2. Okay, I think this is the enough for the homogeneous second order ODE. So thank you for your attention. We will discuss for non-homogeneous in another discussion. Thank you. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.